Ladies and gentlemen, without further ado, it's an absolute honor to bring to the stage Dr. Muhammad Imran Sarwar, Chief Technology Officer of Datalytica Sdn Bhd, to talk about hybrid multi-cloud in the Industry 4.0 landscape. Please welcome.
Testing, one, two, three. Can you hear me at the back? Okay, that's good. Thank you so much for giving me opportunity, Peopleology. And my name is Imran, and I will be communicating and discussing and presenting about hybrid and multi-cloud environment in Industry 4.0 landscape. Okay. So this slide is familiar to you. Maybe you have watched in many areas, many presentation, many talk, that we are in fourth industrial revolution era. Actually, we are in a transition from third industrial revolution to fourth industrial revolution. And in this transition, we have a digitization moving towards digitalization and then towards the digital transformation. So digitization is basically your manual paperwork into digital format, number one. Number two, when you have that digital format, you have a data. And that data has to be analyzed. So this is the data of the past. So you are having a descriptive analytics in your Microsoft Excel or any other file format. So this is basically digitalization, where you are having a visualization of your data, whether it's a process data or basically a different department data, into graphs, a meaningful visualization that will help you in your decision making. Good example is business intelligence, where you are having a data to transform to help you in your digital transformation. So this is digitization, and now we are in a form where we are having a digital transformation. So for the digital transformation is, we have the data, we wanted to use that data to predict what will happen in the future. In terms of future, it's basically can be decisions, can be autonomous ecosystem. So this is basically a transition that we are right now. In some of the countries, the transition is fast. In Malaysia, the transition is good, but after the COVID hit, it becomes slow, but not stagnant. So over here, we have fourth industrial revolution, where the driving element is data. So every industrial revolution, there's some driving element. So first industrial revolution, the driving element was steam. Second industrial revolution, driving element was electricity. Third industrial revolution, the driving factor was two. One is basically automation, and second one was black water. So black water means oil. In terms of fourth industrial revolution, the driving factor is data. So if there's a data, there's a transformation. But if there's no data, there's no transformation, there's no AI. Now that artificial intelligence means autonomous system require data, and that data needs to be saved somewhere. So that somewhere is the cloud. So cloud is in the middle. So there is a dimension which is called digital twin. So digital twin means that on one side we have CPS, cyber physical system, your machines, your sensors, your robots, and then there is a bridge where there is a digital world. So digital world start with the cloud. So cloud in 2000s, early 2000s was used only for the storage and accessibility, where your examples were email, but now it's basically beyond that. So cloud is not providing you only the storage and accessibility, but also computation power, which was cloud 2.0 from 2008 until 2014. The grid computing, cluster computing was an example. After 2014, in align with the fourth industrial revolution, cloud is also providing managed services, where Serene mentioned about native API. So these are managed services, and why we need that managed services? To help you develop an application, Industry 4.0 application, much faster. So in that digital transformation race, whoever will able to take step faster will able to be in a winning position. And that methodology of digital transformation also depends on something called agile. So in industry 3.0, we were looking into waterfall method, where we have a big chunk of application called monolithic. But in industry 4.0, we are looking into modular based approach, where we are having a microservices. So I will use my slide and link with the analogy of industry in Malaysia, especially SMEs. And I will really appreciate that at the end of the talk, if you have a questions, any kind of a questions, you can able to shoot me. Okay. So now, when I'm going to the SMEs for the readiness assessment or consultancy, the first question I ask is, do you have legacy machines or autonomous or IoT enabled machines? 99% the answer that I'm getting is we have legacy machine that doesn't have connectivity at all. This means that they might have a connectivity with the LAN, but they don't have a real-time connectivity with a higher QoS, which is quality of service. So they are not IoT enabled. They are linked. They are PLCs, SCADA-based system attached with MES and ERP, the Industry 3.0 pyramid. But once they wanted to move towards Industry 4.0, the key element is having a real-time connectivity and sending a real-time data to the cloud. That requires some kind of a compliance. So they have two options. One option is to replace older machine with a new, which is not likely to be happen because it requires high investment. The second thing is basically to have an upgradation of the machine, but those machines are basically supported by the vendors and they are not giving us support. So some of the companies in Malaysia, for instance, the SI, they are helping you upgrading your machines to have a IoT connectivity. Why we need to have a IoT connectivity? For the real-time analytics. So this is basically the industrial revolution, the transition happening not only in Malaysia, but also in our neighboring countries. So as you can see, in a factory environment, whether it's a manufacturing or manufacturing services, there are lots of different technologies communicating with each other. So in Industry 3.0, there was no compliance. This means that machine from one vendor like Siemens cannot communicate with the machine of another vendor like ABB. So OPC UA was there to help, but it failed. It didn't able to fulfill its promise. So in Industry 4.0, you will able to see the transformation is going on, and the cloud is playing an important role. So cloud is the brain. So the data creation is happening with your cyber physical system, and it has been saved, analyzed, and give you back the insight by cloud. So when I'm asking the SMEs, do you have a cloud? They say, we don't need one. And I will ask, why you don't need one? Because they said that we already have a server. It is doing wonderful work. I said, really? Okay. Do you have the three environments like dev environment, staging environment, and production environment? And then they will say, good question, we don't have. So when we are moving for mission critical application, when we are developing a Industry 4.0 compliance solution, when we are creating an autonomous system, there must needs to be a benchmark. benchmark of effectiveness, performance, and real-time element, because 1 second delay can make a difference. So that thing can only be happen if you have a good computation power. The cloud computing environment for the multi-cloud is being explained very nicely by Serene before my talk. So I will not go into that detail, but I will explain to you what the local SMEs are facing a problem and how we can able to assist them, understand them, and basically what will be the transformation blueprint and the roadmap. So cloud in the minimum capacity can be private cloud or public cloud or hybrid cloud or multi-cloud. So which one is right for you? It depends. If you are in your early journey of transformation, you may need to use something that can able to fulfill your need as a POC. So you don't need to have a heavy investment. Don't go for cloud. For the POC, you may need your own computer, a small data set that you can able to use to convert your data into value. If you have a structured data, you can use machine learning algorithm, whether it's supervised, unsupervised, or reinforcement learning. But if you are using unstructured data, using a camera, your computer will fail. So what you need a GPU. A GPU that can process the deep learning algorithms. And that GPU can be either in the form of cloud, but even if you don't want it to go for that in the beginning for the POC, you can able to use embedded system, which is edge gateway. Most famous one is Jetson Nano. So in Malaysia, you can able to get a Jetson Nano embedded system that have a connectivity feature, that have a GPU for 300 ringgit. But POC is just to prove of concept that whatever data you are having. If you have a data, it's good. If you don't have a data, you can download from the Kaggle or any similar website. But your main goal is to prioritize which of the use case POC you would like to develop in your journey of digital transformation. So POC will make you prove, okay, you have a data pipeline in which you are doing the data wrangling, cleaning the data. You're doing the EDA, exploratory data analysis. And then you are doing statistical algorithm and machine learning to have a visualization dashboard or value. Once it has been proved, now it's time for expanding it, growing it. So from POC of proof of concept, you're moving towards MVP, which is minimum viable product. Now in MVP, you may need to have a server or a cloud. So the best investment for you to do is go for a public cloud, because you cannot afford to have an infrastructure of the servers and then their license. You cannot able to run Windows 10 on your cloud. You have to use a server edition or data center edition. That is costly. Now when you are preparing your environment, then definitely you need to have different tools, like different services. Now in those tools and services require licenses. So with all of the stack of licenses of everything, it will be a huge capex to be invested. So the best way is to use public cloud in the beginning. Now Serene asked a very important question to the audience and mentioned a couple of times about native. So cloud is basically having an environment in which you can use managed services, but you have the option not to use them, or you can use hybrid, means you can use open source tools as well as managed services. So your code, whether it's in Java, C++, Golang, Python, it can able to run in a cross-platform environment in any cloud, whether it's AWS, Azure, GCP, maybe Oracle. So what should be your pipeline, the end-to-end pipeline for developing a code, having a unit testing automation, having a building that needs to be tested by your QA, needs to have a delivery and deployment so you can monitor them. So you need to have a DevOps pipeline. So in the DevOps pipeline, you have a GitHub or Bitbucket for the source code. You are using different kind of a tool to automate the building process, and then testing process, and then with deploying the process. So this is the basic pipeline that you will be using, and it will be more effective to use cloud because you will have different environment. Dev environment only for the developers to do. Staging environment is separate that mimic the production environment. So staging after that, once all of the bugs are been fixed and you are okay, then you will able to go for the production. But in this transition of technology, you need to also look into the process transformation. You cannot use monolithic application on the cloud because it will able to use quite much resources. So when you are transiting from your server to the cloud, you have to make sure that your application is microservices based. It should not be using any kind of a socket, rather using RESTful APIs. So cloud is pay-per-use or reserve instances. So you have to make sure that you can able to start migrating small bits and pieces in an incremental fashion. Okay. So what about cybersecurity? The general notion is when I'm hearing from conferences or SMEs or MNCs, but mostly SMEs, that, oh, we are using public cloud. We don't need to take care of the security. Cloud provider will do. It's basically a myth. Cloud can able to give you a security or certain level on infrastructure as a service and platform as a service. When you are developing application, whether it's a web-based or mobile-based, you need to consider about OWASP top 10 attacks or SWAT, which is Secure Web Application Testing Checklist, which are broken authentication, access control, error handling, and basically input handling and so on. So these checklists you can able to find from the internet. So your backend developer or front-end developer will able to look into those checklists and implement, because on the application level and data level you must need to take care of the security. Now if you have an IoT system communicating with the cloud, at that place also you need to take care of the security in the form of cryptography. You are encrypting the data, and then in form of hash functions where you are not making it compromise in terms of data integrity, which is the fourth V. Fourth V is veracity of the big data. So volume is taken care by cloud easily. Velocity will also take care of cloud easily. Variety, different kind of a data, will also take care by the cloud easily. And veracity, the most important one, because if the data is wrong, wrong data will be saved, wrong analysis will be done, and wrong decision will be made. So enough of talking of introduction. Let's look more deeper in terms of cloud capability. So when you look into the cloud capability, you will able to see that cloud is providing us application delivery, flexibility, consistency, operation. So you need to have a different pipeline. So cloud is also providing you managed services, so you can able to develop an application effectively. For example, data lake. So all of the data which is coming from different thousands of sensors, devices, machine, cloud will save it, but where? In a data lake. So if the data is structured or unstructured, you need to have a different kind of a databases. If it is semi-unstructured, you need a different kind of a databases. So why not we use object storage provided by the cloud? Like example, AWS have S3 bucket where you can able to save any kind of a data. So the first point of storage is your data lake. Now after that, what will happen? You need to have a pipeline. That pipeline is called ETL, extract, transform, and load, or ELT, which is extract, load, and transfer. So this ETL process will make sure that the data cleansing is happening, and then the refined data is being saved in the data warehouse. And why we need a data warehouse? Because we need to do some analysis. The business intelligence people needs to have an analysis. The CEO or director needs to have analysis so they can able to understand what had happened. So data warehouse, how we can manage it? Through cloud. It is easier to manage in the data warehouse. So optimization in terms of performance, in terms of reliability, mission criticalness, cloud will able to definitely help. But which cloud? That depends on you. So even if you wanted to go for the cloud and wanted to check, you need to consider three things in the public cloud. Number one, what type of managed services they are having. Are they in align with yours? And do I need to spend money on the upskilling or reskilling of my people? Is the resource available? And number three, the cost, which is the most important one. So don't believe me. You go to the Google and write AWS calculator or Azure calculator or GCP calculator, so you can able to have a web page in which you can able to have an estimation of cost, which is your OPEX. So once the data is being transported and refined, what to do with that data? Definitely, one of the driving force for you is to automate things, to make it autonomous. So in case of autonomous ecosystem, you need to have a machine learning or deep learning AI ecosystem. So there are different kind of data sources. That data can be coming from machines, from IoT devices, can be videos, and you need to have a pipeline and then basically a machine learning algorithm. So after applying for all those machine learning algorithm for analysis, you have two things. Either you're controlling the device in a bi-directional way, means IoT sending the data to the cloud, cloud do analysis, refined data is being modeled by machine learning. So either they can be a visualization of the forecasting, or there will be a decision which you are controlling. Example, predictive maintenance. So you are controlling your device. So once the answer is there, then it will go back in the journey back to controlling the IoT device. That mission criticalness is basically important to look into. Another example use case which is very common and very considerable to implement is anomaly detection in your production line. You have a camera and you're detecting is there any defect or not. So that defect means that the camera is taking a video stream of images, sending those images to the cloud. Cloud is doing the analysis and then give back the results. So if the camera is here in your production line, here there will be a cobot whether to reject it or not. So coming from that pin to that point might take 3 seconds. So you need a faster machine that can able to have a capability to return the value within 3 seconds. So if you have multiple production line, this means that you need a even more faster approach. People are saying that, okay, Edge can do, we can able to install Edge gateways before the cloud can. Then we can do the pre-processing. What is the pre-processing you can do in form of images? You can able to reduce the resolution, you can make it monochrome, you can crop it so the cloud doesn't have to do heavy work. So these kind of a consideration you can able to look into. So cloud will provide you managed services, also the computation capability and some kind of a tools that can able to help you in your journey of digital transformation rapidly. So your evolution of DT will be much more faster. So what is the cloud variation we have? You mentioned that there's a public cloud, private cloud, then when to use public and when to use private, and what the hell is hybrid cloud and multi-cloud? There are so many cloud, which one to choose? It all depends on your journey of digital transformation. In the beginning of POC you may not need a cloud, but when you are expanding you need a public cloud because you cannot invest on the private cloud. And once your application is getting bigger, then you can able to have a hybrid cloud. Hybrid cloud means combination of private and public cloud. If I may ask the audience one question, very important question. Is data important to you? Can I have a raise of hand who said data is not important for me? As I mentioned in the beginning of the presentation slide, that the fourth industrial revolution, is driven by the data. So whoever owns the data owns you. So everyone of the audience over here may be using Facebook and Instagram and those applications. So you have accessibility of your data anywhere if you travel, cloud. You can able to load the information much faster, cloud. But that data, does it belongs to you? It belongs to the Facebook if you're using Facebook because you're saving the data in the Facebook. Okay. So if in some cases you have your intellectual property, you have a design that you would like to work on and you wanted to hide it from your competitors, in that case you may have a hybrid cloud because you wanted to use your private cloud to save mission critical data or some intellectual property and public cloud for some other processing. So hybrid multi-cloud means that you have a public and private cloud, and you have a multi-cloud. So multi-cloud can be your Azure or your AWS. So this ecosystem will be reaching this ecosystem means that you are at the end of your digital transformation. You started with the no cloud, but at the end you have a multiple cloud because your solutions are basically in different geographical location. So in that geographical location, just like Sarin mentioned in the previous presentation, that the data is based on the compliance. So if you have a mission critical data or government data or critical data, you don't want it to save outside of Malaysia, for instance. So processing can be done in one cloud, which is in Singapore, and data mining and data analysis and machine learning can be applied in a cloud located in Malaysia. So this is the evolution. In that evolution, we have physical servers. We were using VMwares, very serene. So thank you to the VMware that we have a virtualization that help us a lot. So previously we were having a physical server, then we have virtual machines that make things even much more better. And then this evolution doesn't start at VM. It basically go beyond VM, which is containers. So containers are even lighter weight as compared to VMs. So what we do, Serene also mentioned about Kubernetes. So Kubernetes is a virtual cluster. So like I mentioned, in developing any solutions, you need to have a three environment. One is called dev environment where you're developing your application. Another one is your staging environment where you're testing whether there's a bug. And the third one is your production environment. So there can be a three clusters of Kubernetes running on one virtual machine. So they might be different containers. So when I mentioned about microservices, which is modular based, so each module can run on one container. And group of containers can be encapsulated in one Kubernetes cluster. And it will help us in terms of cost saving, in terms of efficiency and performance. So this is basically, we go for the physical and then we went to the hybrid cloud, and then we have an implementation in terms of on-premise and off-premise. On-premise means your private cloud, off-premise means your public cloud. So after that, we are having a workload division. So in a bird's eye view, if I would like to look into what's going on in the cloud, this is what is going on in the cloud. So you are having a different cybersecurity layer. You have a different database containers, which is system of record. They can be real-time data or non-real-time data. And then after that, you are basically having some implementation of modules. Like thousands of messages are being produced every second by your cyber physical system. So you need some kind of a mechanism to have a cache. So you can use Apache MQ or Apache Kafka. So at least your message will not lose if there is a congestion. So on the server side, it doesn't address the congestion if there is a lot of data. But on the cloud, it can able to expand or in terms orchestrate to multiple instances based on the computation power needed and based on the data ingestion happening. So this is basically, I'm not sure at the end you can able to see, I believe you can do, but if you don't, then I can explain that it's basically different kind of a devices, different kind of a machines, vehicle, even your own asset, emails, everything in the organization are being saved in the cloud, and that cloud needs to be managed those things. So your IT department is handling it. But Industry 4.0, it has one theory. Industry 3.0 say OT and IT. In Industry 4.0, there is no OT and there is no IT. They merge together. So there is a chance that your operators, if they are in your factory, they need to upskill or reskill into different roles. Like 10 years back, there was no data scientist. 7 years back, there was no AIoT engineer who is working on the edge gateway. There was no blockchain engineer 5 years back. So the new jobs are emerging. And who is working on this infrastructure architecture? They are technical architect on number one, who are designing the technical architecture in terms of data, in terms of business process implementation, in terms of data storage and governance, in terms of cyber security, in terms of artificial intelligence landscape, and in also in terms of basically quality assurance. So technical architects are one. Those technical architects can be further divided into cloud architect, data architect, AI architect, cybersecurity architect, or infrastructure architect. This is the architect team which is doing the specification even before we write a code. Then comes your technical team. So in the technical team, you have a front end person developing the front end, back end cloud engineer. Then you have data engineers whose responsibility is to create a pipeline from the data lake, data ETL pipeline or ELT, and the data warehouse and do the automation. So this automation process is called data ops. It is a responsibility of data engineer. Then once you have the data scientists on your POC will able to convert that data into your value. Then you need a ML engineer or DL engineer or AI engineer to work on the artificial landscape of converting that data, whether structured or unstructured, into a process. And that AI process is called AI ops automation, where you have a different machine learning model for different kind of a data, different kind of use cases. And all of these things are on top of your DevOps pipeline, where your development and operations are basically happening. And this whole ecosystem is basically your Industry 4.0 operations, which will be only be happen if you have cloud environment. So public cloud, you will be leveraging to develop an application and computation, and private cloud you can use for data. Okay. So the difference between what is the hybrid cloud and multi-cloud, it was a bit clearer on my screen, but it's not that much clear on the PowerPoint over here for the projector. So we need to look into important considerations, and those considerations are compliance and regulation, cybersecurity, vendor lock, business resilience, innovation, and cost model and cost optimization. Vendor locking is you are developing an application using the managed services of the cloud. You can still use open source or cross platform, and that cross platform application can run on any cloud. But if you are using a database, for example, like RDS, which is basically managed by AWS, then you are in a deep problem later. Then compliance. So in the compliance, basically hybrid cloud is more on-premise and basically on the public cloud. And multi-cloud is basically used for different purpose. So what are those purpose? I will tell you in shortly. I will skip that because previous presenter have mentioned. So what is the advantages of multi-cloud approach? So either you can go for multi-cloud or you can go for hybrid cloud first. So the transformation is no cloud, public cloud, and then after public cloud, you go for hybrid cloud. And then after hybrid cloud, you can either go to multi-cloud. So hybrid cloud is for your data security ecosystem, or basically something which is more you are dividing computation in the public cloud and data processing locally. And either if you are having a very data intensive application deployed in a large scale enterprise level, then you have to consider about hybrid multi-cloud. So advantages of multi-cloud is it will make you avoid vendor lock. You will be developing a cross-platform application which can run on any cloud. So you can kick one vendor and then move or migrate your solution into another vendor anytime. Number two is cost optimization. You can able to have, for example, AWS Spot instances and secure computation. And then for the low priority tasks, you can able to give it to Azure, for instance. Security is very good if you have multi-cloud for the different domain and different region. And at the end, data governance. So once, if let's say we have a data center or VMware, for instance, in Malaysia, then you can able to store the data in Malaysia as compared to having a storage in AWS, which is not in Malaysia, for instance. In terms of disadvantages, we have a complexity, means that you need to have manpower to learn about managed services or working with two different clouds. So you need more manpower. And then cloud development and DevOps operations might be difficult. And how you plan which thing to be run on which cloud is also important. The first consideration is always cost optimization, how you can lower your OPEX. And last but not the least is about cybersecurity. So cybersecurity is something that you need to consider on every pillar. IoT have a different requirement for cybersecurity, edge have different, cloud have different. Data at rest. Data at rest means data which is saved in the cloud. It needs to be encrypted as well. And then what should be the AI cybersecurity consideration? So there's an end-to-end ecosystem of cybersecurity implementation. Definitely cloud will provide you much more secure environment where your data is not being hacked. Have you heard about TM data is being hacked, CIMBA data is hacked? Are you receiving an SMS, for example, about your things? Are you receiving a call of LSDN that, okay, your tax is not being paid, or something like that? But they are from mobile phone rather than a local phone. So what happened? How they able to get your IC? How they able to know your name, your spending, your tax information, because they didn't implement this thing. If they are using a hosted service which is not having a consideration of cybersecurity, this will not happen. So I have a good news and bad news. Which one you wanted to hear first? Bad news or bad news first? Every single of us in this room, our data is available in the dark web. Good news is there is still a chance that we can able to save our future data by implementing proper cloud strategy. Mm, okay. So hybrid cloud are very fast. I will mention what are the architecture characteristics are. Basically, you can have a on-premise, private or public. It depends. But important aspect that I would like to mention about hybrid cloud is you can use your server and you can install Azure Stack or AWS Stack, but you need a processing power. So first go with the public, then hybrid, and then go for the multi-cloud. And that will able to be in your journey for the digital transformation. So what are the scenarios for the hybrid cloud? It's dynamic. It can give you a critical workload. There will be no problem of a fall. Big data processing. In your journey, where you are having a data bigger and bigger, because data is coming, right? It's getting bigger and bigger. So for big data processing, either with Apache Hadoop or Spark, your server will not able to help you. So you need to have some cloud environment to basically have the ecosystem where you can have a big data processing or big data analytics. Okay. Flexible and basically best of both ways. You can have leverage the private thing and also public thing. Let me give you one secret. When you are basically having a cloud costing, you need to consider about CPU, RAM, and disk space, right? But for the deep learning use case, you have to consider GPU. So GPU-based tasks are very expensive. So maybe you can consider putting them in your local cloud, which is private cloud, and CPU-based heavy intensive you can able to consider as in the public cloud. By the way, when you are having a data saved on the cloud, you also need to pay for it. So the best thing is to use different services. If they are in S3 bucket or in a database, you can put it in AWS Glacier if you are not using it. So the cost will be down. And who can advise you? Technical architect. If you don't have one, you can able to hire. Or if you don't want to hire, you can contact me. So what's next? Final slide. What's next? What we need to do, basically, we need to look into the aspect of people, process, and technology in your organization, where you able to help yourself by implementing digital transformation. You can think big, but start small. Start with the edge gateway, then public cloud, and after you have developed the MVP, then expand yourself either to multi-cloud or to the hybrid cloud, depends on your need. But do consider one thing. Think about OPEX, CAPEX, security, and time to the market. I will really be appreciate if you have any questions, I will be more than happy to answer. Okay. Did I scare you guys? Little bit, okay. It's good. That's a good news for me. Little bit. So in your digital transformation journey, for the hybrid and multi-cloud, you need to go first with the public cloud, then hybrid cloud or multi-cloud because it will able to help you. And for upskilling, try to choose a vendor that have a course, free online course. Okay, so the most famous is Azure or AWS. You can check Azure or AWS, they have some free courses. So you don't need to have a certification. You can start with the online tutorial first. With that, I would like to thank you for listening to me and such a good audience because I didn't see any snoring or sleeping with me. Thank you.
That's Thank you, Dr. Muhammad Imran Sarwar, Chief Technology Officer of Datanalytica Sdn Bhd, for the insightful sharing. I am glad to invite Ms. Kelly Yao to present a token of appreciation to Dr. Muhammad Imran Sarwar for sharing eye-opening information. Please welcome.
Thank you very much. Thank you. Thank you. Sure, thank you.
Thank you, Ms. Kelly Yao.